So I'm James Cadd. I'm a program manager at Microsoft. I work in the Windows Developer Platform group, and one of my areas of focus is WebRTC. I'm joined today shortly by Max Zilberman, also at Microsoft, and Raymond of OpenPeer. So today, we would like to talk to you about native WebRTC and ORTC app development for the Universal Windows Platform. I realize most people here are probably not familiar with UWP. So just a quick background, that is the app platform that shipped with Windows 10, and it runs across all of our devices. So you can build a single app. It runs on Windows Desktop, tablet, mobile, Xbox, Raspberry Pi, HoloLens, Surface Hub, and I think that's it for now. So literally one app, one package, one store submission runs on all those devices. And what we've done is taken Google's WebRTC source, ported that to UWP, and spent a lot of time optimizing it. So this is a highly optimized port. If you put it shoulder to shoulder with the Win32 version of WebRTC supplied by Google, this is significantly more optimized. So even if your only target is a desktop app, I'd still highly recommend checking out this library. So Max and Robin, I see you guys over there. Hello. Can we hear you?
You can when we unmute.
Awesome, guys. Well, I went ahead and did the intro, so Max, over to you.
Great, thank you, James. Would you please move to slide 3?
Yep, good.
Excellent. So as you can imagine, for WebRTC, there is a quite wide range of options. You can write an app in a browser, you can create a native application, or you can just take an application and attempt to host it in a web view. And experience differs quite broadly between the two. So when you look at the web browser, of course, can target as many devices as possible, and it's fluid and dynamic. You can launch Chrome or Firefox and very soon Edge and write an app. But if you need to make a call, that's when it sort of breaks down. Now you go to the native app, of course, the challenge is the opposite, right? You can have an app, but you have to install it. While at the same time, you have significantly more capabilities of what you could do. And you guys know this. I'm not gonna belabor the point. James, next slide, please. But the idea is that the challenges differ, right? And if you ask which way is the right way to write an app, should you go HTML? Should you go native, whether it's C++ and C# or JavaScript? It really will differ between what your developers are comfortable with. So when you look at the options that we've provided as part of the Universal Windows Platform, is you can actually take your skills using HTML and JavaScript, or your skills plus, and you can develop an app using those skills. You don't need to be molding your developers to a brand new platform, a brand new language, in order to take advantage of the broad range of features. So I'm going to turn it over to James, and he will show you a native application written using JavaScript.
All right, thank you, Max. So this is a port of AppRTC to the Universal Windows Platform. How many people out there are familiar with Google's AppRTC test site? Probably have used it before, yeah. So what we've done is taken that AppRTC JavaScript code, wrapped it in a universal Windows app package so it runs on any platform, and shimmed over their WebRTC calls from the browser over to our native DLL. So what we're going to see happen here is I'm going to go ahead and launch this in Visual Studio. Notice I have a breakpoint set here. So AppRTC pops up. And hopefully, Max, you're waiting in a room as well. So I'll give you a number, okay? So this UI should look familiar, but this is a native Windows app, works on mobile. I go to join and I hit my breakpoint on Get User Media, which you should all be familiar with, or the WebRTC folks out there. I'll go ahead and continue that. Head back to the app. All right, so Max, you ready?
Yes.
Okay. 230-947-883. So same UI you're used to seeing in AppRTC, no modification there. Max just joined up, and we've got a video feed in a native app. Hey, Max. All right. There we go. So that's AppRTC. AppRTC is relatively simple. It's a foreground-only app. A device doesn't ring when someone tries to contact you. Both users have to have it up and running at the same time to see it. I imagine some folks out there have built what I would consider to be a full VoIP experience as well, which is something where you can ring a user's device. There's probably integration into call history, the contacts list, all of the OS things that a user expects from a VoIP app, as well as the app has to be able to handle running in the background, right? So if you start up a video call in your app, user navigates away, they're using their phone, that audio call keeps running. If they switch back to the app, the video call comes up quickly. And I want to let you know one of the things we ship is a full-scale VoIP sample called Chatterbox. That sample runs on WebRTC, and it gives you a complete VoIP experience. So for a demo of that, I will take my phone, and you're probably not used to seeing a call, well, similar to Skype. The call will come in on PC. I'm just going to initiate it from the phone. Oh, there we go. So if I'm lucky, I'll get a ring here in a second. Or maybe not, but that's okay. At any rate, we ship a full VoIP sample for you, so out of the box, just file new project, you've got a complete VoIP sample. So now over to Robin, I believe, to talk about ORTC.
Robin, you muted.
Yeah, I'm there. I'm just waiting for myself to come up on the screen. Are you able to hear me?
We can see you and hear you, Robin. You're ready to go right now.
Oh, perfect. I didn't know there was two screens, so that makes a lot more sense to me now. Okay, so my name is Robin Raymond, and I'm the lead contributor to a project called ORTC Lib. And so I'm going to walk you through a little bit of what that is all about. So next slide is to what is ORTC Lib, or previous slide to that, James. Okay. So it's an open source implementation of the ORTC community group specification. It is not just a demo, it's a full-on usable implementation that you can integrate into your projects. It does have a C# and C++ object API interface with all the standard ORTC objects that you may or may not be familiar with yet. It is very mobile focused. It has a very advanced ICE engine, and I'll highlight some of the features of what this ICE engine can do. It is compatible, of course, with the standard ICE that is available as well, so it does interoperate just fine. And it includes a migration path from WebRTC to get you going, and then to introduce you to the ORTC way of doing things. So before I begin, next slide, please. I'm going to highlight some of the features on the enhanced mobility stack so you can understand some of the stuff that we've been working on. So in our implementation, our ICE never completes. You continue to do network discovery throughout the call. So if your Wi-Fi or LTE comes up and down or whatever you have going on, it can discover that new network path, automatically switch to it if it's a better path, and switch back if your primary path fails. So the idea here is to keep a stable network connection and do Wi-Fi LTE handoff, and this actually works. It does do temporary failovers as well. So if your primary connection should go down and it discovers that rapidly and switches over to a backup and then switches back when your primary comes back. It does allow you to do keep multiple network paths warm, so you can keep your turn server warm as well as your firewall warm, so you can always go back to your turn server if need be, as an example, or even keep LTE and Wi-Fi hot if you want, although I don't recommend that for battery reasons. There's also something called turn mobility ticket, and that's something we use to maintain a stable IP and port on a public IP address somewhere, so that if you are roaming and your IP addresses completely go sideways on you, you always can maintain a stable IP and port from the remote person's perspective that allows you to reconnect under most scenarios without even having to necessarily signal back. So that's a really great little feature that we support, and that is also available in CoTurn as a service, server service. So next slide. The other thing I wanted to mention that ORTC does is it differentiates testing priority versus your preference of which you actually want to use. And let me give you an illustration of that point. So when you're doing your ICE connectivity checks, what you really want to do is you want to get your connection going as quickly as possible. So usually what you want to do is you set up your turn first, and then you try your firewall, and then you try your local LAN. And ORTC lib understands this inherently. So most people, will gather their turn candidates, hold back their local candidates, and give like 3-second rule or something like that to get your turn working, and then you try your local. Well, ORTC, you don't need to do any of that. You just say it already understands that logic, will automatically test and get your connection going up as quickly as possible, then optimize out the least favorable and relay paths. So next slide. So I want to highlight just a few things and some differences here between the different ORTC lib and ORTC implementations. So ORTC lib contains all of your objects that you would expect in your community group specification. It includes the listener, the transport controller, it includes the data channel, SCTP transport. It is meant to be a full-on one-for-one implementation, plus even some additional stuff that you might need for mobility to get going with ORTC lib. It does include lots of stuff, some stuff I already covered, but some additional stuff like simulcast. You can fork the code because it's open source. It has certificate management APIs. You can control your DTLS transport certificates. Mobility ticket I covered, trickle ICE, aggressive ICE, normal ICE, continuous ICE nomination, and you can even filter what you want to use for your different network paths or not. So it's a very, very powerful engine. There are some differences between us and the Edge implementation, which I'll highlight. Edge right now contains H.264 UC, which we do not. It also contains Silk, which we do not. And it has the legacy MS turn and MS ICE, which we are compatible with, but we do not support directly. And they also include happy eyeballs, whereas we do that through our preference versus priority separation. So ours does it in a different mechanism, but they do happy eyeballs as well. And if you want to know what that's about, I suggest doing a Google search on happy eyeballs. It's kind of an interesting side note and thing to learn about. So the next slide, please. So there may be some of you who are not really ready to take on ORTC's API because it is a little bit lower level than you might be used to. You might not quite understand what it's all about and what it can give you. And so you might need a kind of a migration path. But let me illustrate some important points here, is that objects are coming. They are already here as part of the WebRTC specification. If you look at today's latest spec, it is there already. They don't have all of the surface points that ORTC does, but the specifications are merging. And so what you're going to see out of WebRTC is going to include all of what is capable in ORTC eventually. So it's a good idea to get familiar with what ORTC can do and learn what it's all about. But ORTC lib does include an adapter layer, which might be your answer if you need a migration path and you're trying to implement a native app. So next slide, please. So what you can do with ORTC lib is you can use your standard STP mechanism that you're doing now. You can implement against the same peer connection API that you have with WebRTC, as well as with the same media stream objects. And it has all of the APIs and surface points that you need to do a peer connection right now. And what it will do is that adapter layer will talk to the ORTC lib objects and control them on your behalf through your peer connection interface. So if you don't want to learn how to do ORTC lib objects right now and how they work and take advantage of them, you can certainly take advantage of the mobile light stack that's within ORTC lib right now through this existing peer connection interface. And when you're ready later, you can take out that layer and start doing some really cool stuff that you can go to over with the ORTC lib, and that's a whole different subject I don't have time to cover today, but some stuff like you do, instead of STP negotiation, you can do an offer answer, you can do a capabilities exchange, which is a nicer, cleaner way to get endpoints talking to each other. But that's for another day. So I'm almost out of time, so next slide. And I just wanted to say that this is a community effort. So we invite everybody to participate in this. This is a completely open source project that anybody can come in and contribute, either directly through code, or if you want to help financially, that's wonderful as well. Right now, we do have the UWP and WinRT windows ready, so you can take this as a C# implementation and use it. I'd like to test this on other scenarios as well in the future. We are hoping to do things like with Xbox and IoT on the Windows platform, as well as do cross-platform C# on iOS and Android. We already have it compiling on those platforms, but we need to have the wrappers exposed at this point. We would also love to see JavaScript and TypeScript, support wrapping all these platforms. We have simulcast now, but we'd love to add scalable video coding to this library. And we'd love to include a whole bunch of great examples around the JSON style capabilities exchange, and to demonstrate what you can do versus STP, which would be really cool. So anybody who wants to contribute this, just reach out to me, robin@openpeer.org, and I'd be happy to discuss and see what we can do and how we can progress in the future. Thanks a lot, James, for inviting me to this. And I'm going to hand it over to Max, who's going to talk about some really cool RTC tooling available on the Windows platform.
Excellent. Thank you, Robin. Just a few things to highlight of some things that James said previously. The port that we did for WebRTC and some of it that we've done for ORTC has actually substantially replaced the way we handle media in general. So as you know, the WebRTC stack standardizes on the H.264 implementation from Open to H.264, as well as default media handling on a desktop using the classic WebWin32 API. And what our team has done is we've moved to Media Foundation that allows the media to be handled in a very battery efficient manner. So we've tested the implementation to run on the lowest of the lowest end phone, which is a Lumia 520, to the highest end Surface Book. And can you guys hear me well?
That's better, yeah.
Okay. To the highest end devices such as Surface Book, where we're able to go 1080p at 30 frames a second without even breaking 30% of CPU. So with that, of course, comes some challenge. Next slide, please. And that is, as we began developing WebRTC for Windows, the one thing that became evident is the classic Google dashboard in terms of WebRTC performance just wasn't going to work very well. And so what we did is we integrated the WebRTC sync infrastructure, or sorry, the logging infrastructure directly into Visual Studio. So next slide, please. Actually, skip two. And what we're going to do is we're going to show you a video of WebRTC tooling running, and I'll just narrate over the video. So what you will see is the classic performance analysis tools. It will be available just like you do any XAML analysis. So what you're seeing now is a WebRTC application, Chatterbox application being launched. We enable ETW tracing to be emitted from the application. And now what you see is you see several swim lanes within the Visual Studio interface. Each swim lane represents a counter. We track over 70 counters, including some that are not actually available inside WebRTC source. So for example, we're able to judge the exact quality of video and resolution changes and frame rates that come directly from Media Foundation. So you're not only getting perceived performance that is being reported by the Google counters, you're getting the actual emitted performance that we see on the device. So instead of just looking at performance counters and guessing why things happen, you're able to judge why you're able to see things happen directly in the app. What you see on the very top of the graph above the swim lanes, you see little hash marks. Each one of those hash marks represents an event. And this event, for example, mute, unmute, resolution changes, SDP exchange, and ICE candidates. You can see all those things in actual detail. So you could see that a resolution was changed, or that device was muted, or the call was answered, or a message was sent. So you have a very clear understanding of why things have occurred. And that's about it for tools. In each swim lane, you will actually begin to see counters as a line graph, and those counters represent the actual values. You can explore them, so you can highlight a region, for example, and zoom in, and you can also look at raw value and even export raw values into Excel or CSV. So you have a very wide range of capabilities. We would like to continue making great tools, but not without input. So if you have input, definitely please let us know. James, over to you.
Okay, thanks, Max. So to wrap up, we'll just stay here. So to wrap up the roadmap forward for WebRTC and ORTC library for Windows, we're going to keep WebRTC current with the Google source. So we'll do periodic pulls, merge, update our code, and push that back out. ORTC is going to stay current with the spec, so we'll make updates as the spec evolves. And you can get this now. It's available on GitHub today it's available on NuGet today at the address you see here, and will be up on GitHub soon. So we're going to keep this open source and publish everything we've done. And a few additional resources here, and email to get in touch with us. And that's it. We're all set. So I think we've got a couple of minutes for questions if anyone has a question.
We've got time for one question. So make it a really good one. Over here. For a second, I thought that you were raising your hand, and then I realized you were just stretching your cables. See, he who hesitates is lost.
So let's see if I get yelled at for this question. Since you guys seem to be slightly ahead in terms of OS support of both Android and iOS, is Microsoft considering providing some kind of library app ORTC support for competitor OS platforms? Specifically, right now, it's a pain to add WebRTC, including signaling and media handling to mobile apps, right, on all three platforms. And you guys are saying that for Windows 10, yesterday, I think Max mentioned that you're releasing a way to do it more easily. Are you considering adding some Microsoft library or apps to help with that on iOS and Android?
Gotcha. So you're right. Good question. So the ORTC lib that was built is part of an open source project, right? And it's as such, it's cross-platform as you would expect it to be. Microsoft in particular isn't necessarily focused on the Android and iOS versions of ORTC. But that said, we are very interested in building the Windows source and where it makes sense to push that down into a common piece of code that's shared with iOS and Android, then we're happy to do that, and that's the right thing to do. But again, our focus is really on Windows, and we expect that the community will keep the other two up to date as well. Okay, thank you.
Thank you.
Yeah, and in addition, just adding a comment to that, we're definitely interested in adding Xamarin support, which will make it cross-platform in one way. And I'll let Robin speak to direct support of iOS and Android.
So we do have hopes and plans to take this ORTC lib and add the Xamarin support, which would give you C++ on iOS, C# and a C++ library on iOS and Android. I'd love to do the native wrappers. It really comes down to time. It takes a lot of times to do the wrappers on all the platforms, and more importantly, all the samples that are involved. So we have to pick our battles. So I'm thinking, given the ease of writing one language for all the different platforms, it probably makes sense for us to concentrate on the Xamarin platform with C# first, and then to do something native afterwards. But I'm certainly open if people want to help out on this effort to do native as well. We just got to pick our battles.
Excellent. Well, with that, thank you very much, Robin and Max and James. Thanks a lot.